Welcome to this class, SVG 201. Now, today we are looking at measurements of magnetic directions or bearings. Measurements of magnetic directions or bearings. In surveying, there are various means by which you can determine your position. Various methods, various equipments, depending on the capability, depending on the availability of cost and time. All of these things will determine how precise you are going to be. Your position could be determined. But now we want to look at using a compass. A compass to determine bearing of a line. When we talk about bearing, first you need to get the difference between bearing and angle. Bearing of a line, we normally term this one bearing of a line, while you measure angle between two lines. Let's look at this for example. This is a line, normally a reference. From a reference, let's call this one north. This is another line. We can determine the bearing of this line from a particular direction to this direction. Another thing, you can determine angle between two lines, theta. But we are talking about magnetic bearings and directions using compass. From the word magnetic suggests that the direction, the reference line is from a magnetic north. This is the reference, magnetic north. Magnetic north. So you take magnetic bearing takes effect from magnetic north to the desired line. Assuming this is a point you aim at, point A. Point A. You are at a point O, origin. You carry your compass. We'll come to know about compass later, how it looks like. We'll show it to you. So if you want to use this to measure, that compass measures magnetic bearing with reference to the magnetic north. So magnetic bearing is the angle between the direction of the line and the direction of the magnetic meridian at the beginning of the line. This is the beginning. This is where you are. This is your origin, where you are standing. So it's the angle measured in a clockwise direction. Take note of that. It's in a clockwise direction from the point to where you are standing to a point you aim at. Then we have also meridian. But before I go to explain that meridian, the compass you are using, anytime you hold it, the principle of compass upon which it is based, whenever time you hold your compass, because we have it contains magnetized steel. That magnetized steel is pivoted at the middle. Whenever you hold that magnetized steel, if you have any steel, that's the principle. If you have any steel like this that is magnetized and you pivot it at the middle, when that steel, magnetized steel, oscillates or rotates, it should definitely come to settle at a point. Because it's under the influence of magnet, whenever it comes to settle down, it's going to point in a particular direction of north-south. Whenever this one settles down, this magnetized steel, the needle, once it rotates and it comes to settle down, because it's under the influence of magnet, it will point to the direction of the north and south. And that's why we call it magnetic north. So, because of that magnetic north, you now have what we call, because of the magnetic north, we have to now place something on it to help us to do carry out measurements. Because you know, angle at a point is 360 degrees. So if you stay at a point, if you rotate the graduated ring on the attached to the needle, the magnetic needle, will help you to let you know how you are moving. So don't forget, anytime you hold your magnetic compass, it will always point to the direction of the north anytime it settles down. So as you keep moving, it will always point in the direction of the north. So as you turn, anywhere you are aiming at, the needle will always point to the direction of the north. Anywhere you face, then you cannot measure the remaining angle. So that is that about a magnetic meridian. So now let's look at the true meridian. True meridian is the line or plane passing through geographical north pole, geographical celestial pole, and any point on the Earth's surface. What you are saying here is that you have a sphere. We have the celestial sphere, and we have the Earth. The Earth is at the center of the celestial sphere. The Earth is here. There's a circle, a great circle, that connects where is what we call the north celestial pole, and we have the south celestial pole. The line that it passes through the non-celestial pole and the point you are on Earth's surface, you can have a point, you can be at a point there. But this Earth, the whole of Earth here, the line that is passing through the non-celestial pole and the point of observation wherever you are on the Earth's surface and the celestial pole, south celestial pole, is what we call the geographical meridian. Geographical meridian. And that is also what we call the true meridian. True meridian. And it's always constant. Unlike the magnetic meridian will change from year to year. It changes from time to time. And that's why when you are carrying out azimuth observation, whether by star or by solar, I mean solar or stellar. Stellar means star and solar means sun. Either of the two, you always take your determining your location using the geographical meridian. So that's what we do. So in that situation, I will put it this way again. So let's take the geographical meridian as the true north now. It's also called the true north. The true north. I told you that magnetic meridian can swing to either of these two sides because it is not stable. Over the year, 100 years, 50 years or more than that, it will go to change gradually. So it can be on this side, maybe in another 100 years, it's going to be on this side. But let's assume we are just here, for example, now, magnetic meridian. Call this one magnetic meridian. So there will always be a difference between the magnetic north and the true north. And That difference is what we call declination. Declination. Declination is the difference between the magnetic north and the true north. The true north. So it's either on the western side or the eastern side. So whatever it is, we have the declination. It can be positive or positive or negative. Yes, go on. So I'm here. I try to show the magnetic, the geographical meridian there, and I've shown us the Earth here, North Southern Pole. Go down. Aha. You can see now. This is the true north. This is the magnetic north. So if you want to measure now with your compass, the bearing you determine from a particular north, usually the magnetic north, that bearing is called magnetic bearing because the reference line. If your reference line is from the true north and you are measuring to a particular line, we call it true bearing. So magnetic bearing is with reference to the magnetic north, while true bearing is with reference to the true north. So at every location on Earth, there are magnetic north. There is always declination. Declination showing us the difference between true north and magnetic north. Look at this angle now. Magnetic bearing is from here, this line, then to this line. We want to know the magnetic bearing from A to B. So it takes effect from the angle here to this. For the true bearing, maybe for this line, let me make a proper something. So if you have this, after you have equal planes of equal height, we call it contour lines. So likewise, when you have planes on Earth's surface, when you draw the map showing declination of places, planes that have equal declination are referred to as, we have a line, we have a map that shows planes of equal declination. And when we join them on maps, then that line joining in place of equal declination is what we call isogonals. While planes of zero declination, that is where compass magnetic north coincides with the true north, are called agonic lines. In some cases, you are likely to have your magnetic north coinciding directly with the true north, but which is very rare. But when we have such, that is, there's no difference between the true north and the magnetic north, such places are called, line joining those places are called agonics. It means that at those points, the declination is zero. Now, how do we designate magnetic bearing? Depending on the type of compass you use, we have two major types of compass. We have what we call Surveyor's compass, and we also have prismatic compass. Prismatic compass. A prismatic compass will measure with respect to from the north. You know, when you 360 degrees, as you stay at a point here and you turn. At this point, angle at this point is 360. And if you remember our four cardinal points, we call this one north, south, east, and west. Prismatic compass uses whole circle bearing, that is from 0 to 360 degrees. While this Surveyor's compass uses quadrant, and that's 0 to 90, based on different quadrants. We have 4 quadrants, and 4 quadrants to make 360. So if you can record your bearing in either of the two systems. The first one is old circle bearing. I mean, this was the first one. Prismatic compass use old circle bearing. Old circle, that is 360 degrees. So once it starts from 0, it gets to 90, it gets to 180, 270, then 360. So as it's turning, it's progressive. The compass is measuring up to 360. I mean 359. So the last one, 0. If the next one is going to be, instead of writing 360, you write 0. So 360 is the same thing as 0 for magnetic compass. So in that case, that compass, prismatic compass, uses old circle bearing. But for quadrantal, for a Surveyor's compass, it uses quadrantal bearing system. That is, it measures in 90 degrees. 90 degrees. 90 degrees. So, but quadrantal bearing, I mean, Surveyor's compass, it makes use of this. It makes use of this line. It makes use of this line. Let me show it again. Its own reference is from this line. While prismatic compass, its own reference from 0, it goes on like that and come. But for a Surveyor's compass, it uses this line. It can be north, south. It's reference to from, it takes its own reference from north or south. How does it go about it? You must have been familiar with this. Now, if there's a point here to be located, it will only measure, it cannot measure beyond 90. But it will indicate where is it coming from and where is it going towards. For example, now, if I want to record this one now from using Surveyor's compass, it will tell you how far it has moved from the north to its direction. So in that case now, you can say north 45 degrees east. And that's what many of you are familiar with if you did geography at secondary school. From the north, it has traveled 45 degrees towards east. This is it. They might tell you in your mathematics of secondary school, they will tell you a ship is heading towards the east. It took off from the north at this 36 degrees from the north, is going towards east. What they are telling you is that they have used Surveyor's compass to take that measurement. If it takes from here or from here, let's call this one A, B, C. If you want to determine the bearing of this B using Surveyor's compass, it will take reference from the south. I told you it's either from the north or from south using Surveyor's compass. In case now it's going to take it from the south and go this way. For if peradventure the angle between here and here is 30, it will tell you south from south, it has moved 30 degrees towards east. That's why you have southeast. If it is at sea, maybe this is 20. It will tell you it's moving towards southwest, from the west towards west, but took off from south. You now write south 20 degrees west. And these are the two ways of presenting. But sometimes you may decide to convert this Surveyor's compass reading to a old circle bearing reading. In that case, if this one is 30, it means what are we left here with is 60. It means from 90 plus 60, that will be 150. So it means if prismatic compass is to be used, what gives us as S30 degrees east will be 150 degrees, old circle bearing. in that case, if you were given this as observed with the equipment, with a compass, with a Savius compass, if you convert it, you change it to O-circle bearing, which is, you didn't observe it, but you only calculated it and reduced it this one. In that case, we are now going to call it a reduced bearing. Reduced bearing. That is, not observed directly, but was reduced, was calculated, was deducted, was reduced. That's why they call it reduced bearing. Next one. So you have O-circle bearing, quadrilateral bearing, and the last one there is the reduced bearing. So we can see now that we can convert a O-circle bearing to a reduced bearing. You can equally convert a prismatic compass, or quadrilateral bearing rather. You can convert quadrilateral bearing to reduced bearing. You can convert O-circle bearing to reduced bearing. You can move either of the, you can switch either ways. So this is the term used when you convert a particular quadrilateral bearing or O-circle bearing into another reading. You can look at that table. That table. So you may be asked an exam to find what is the equivalent of this one. What is the reduced bearing of this one? So you will just tell us, like this end 45 degrees in O-circle bearing is also going to be 45. So in that case, what is the reduced bearing of this one? Just say it's 45 degrees. But if something is here now, it means I have to add all of this one, 90, 180 plus 2. That 20, that will be 200 degrees. So the equivalent of this one in reduced bearing is going to be 200 degrees, while in quadrilateral bearing is going to be south 20 degrees west. And for forward and back bearing is just, if you go in a particular direction, if I'm moving from A to B, assuming the bearing is 45 degrees. If I observe at A towards B, I observe 45 degrees with my compass. If I get to B and I turn to site A from B, it's going to be plus or minus 180 added to or subtracted from the initial reading I took. If I'm at A, I observe towards this one, that is 45 degrees. If I get to B, I want to look back here, it's going to be 45 degrees plus 180, which is 225 degrees. It means that if I come here, I place my 4 cardinal points there. You will see this 0, 90, 180, you see now it will fall there as 225 degrees. In the situation whereby the angle is more than 180 degrees, the opposite of it, when you get to the other end of the line, is going to be you are going to be subtracted from 180. Subtract 180 from it. For example, if I observe a bearing of a line 230, that is bearing AB. If I say AB is 230 degrees, what is going to be BA? The point where you stand to observe is what you normally write first. So if I stay on A, I observe towards B, I call it bearing AB. If I stay on point B to observe towards A, I call it bearing BA. So if I give you the bearing of AB to be 230 degrees, what is going to be the bearing of BA? What you just do is to subtract 180 from there, and that gives you 50 degrees. So it means that it's on a straight line. Angle on a straight line is 180. That's what we learned in mathematics. So just subtract 180 to it. But in case your line is 450 degrees. It's not up to 180. So, and you want to get to the other end of it, you just add 180 to it. So it's either you add 180 or you subtract 180. That's what is being demonstrated there. So you're going to learn more about all of this later. So determination of true bearing and magnetic bearing. True bearing equals to magnetic bearing plus or minus declination. This is where to how to calculate true bearing. True bearing is magnetic bearing plus or minus declination. Then magnetic bearing is equal to true bearing plus minus declination. Say that way. So it means we can convert. If you are given magnetic bearing, you can determine what is the true bearing if you know the declination of that place. So that is that possibility. As an example, you still have other ones to do. The magnetic bearing of a line is 120 degrees. Let's call this one 120 degrees. The magnetic bearing of a line is 120 degrees. What will be the true bearing? This magnetic bearing. What will be the true bearing if the declination is 5 degrees 15 minutes west? This is 5 degrees. These are the western part. Declination is 5 degrees 15 minutes west. It means that declination is negative. So it means that the magnetic bearing is here, while the true north is there. Magnetic north is this, true bearing is there. And magnetic bearing is given as 120 degrees. So what is going to be the true north? True north will be the angle taken from here to this place. In this case now, if 120 runs from here to here, what will be the angle here? So what you do, you just subtract 5 degrees 15 minutes from 120. That gives you 114 45 minutes. It means that your true bearing will be from here up to this one. Again, if the bearing is given, magnetic bearing is given as 120 degrees from a particular reference line, and it means magnetic bearing is taken from magnetic north, and we said that the magnetic north is on this side of it, of the true north. What is going to be the true bearing? So you just look at, if you make the diagram, it will make it easier for you, and you have this as your true bearing. Now let's assume that the declination is on the other side here, is positive, 5 degrees 15. Assuming the magnetic north is here, meaning that the declination is positive. So 5 degrees 15 minutes. It means that the magnetic north is here. So if the magnetic north is here, because the declination is here, and they said that the magnetic, this is true north, magnetic north is this, and we have taken my magnetic bearing from the magnetic north, and it gives us 120 degrees. What is going to be the true bearing? The true bearing will be from this north, this true north. It means that true bearing will take it first from here to this one. So it means that we are going to add this one to that to make 120 plus 5 degrees. So that will be 515. So 125 degrees, 15 minutes. That is the true bearing. Because Here we'll be adding the declination to be positive. And what the declination west is negative. So one. It's 5 degrees from. It's okay. So we have come to the end of the lecture. So what you need to do now is to do the assignment at the end of this lecture note. We have 1, 2, 3, 4. So you will, on the assignment, I will make it, I place it there for you to do and submit. Thank you.